Right now I am being tempted to think that you already have this file on that you have downloaded it from our Telegram channel, and I know you have it, so you can follow along as you see this. As you watch the video, we go through together. This one is the vector product of two vectors. We are saying that this is known as the cross product of two vectors. The other time we had a scalar dot product, and it is actually dot product, but the name scalar dot product comes from the fact that the result you get is a scalar quantity. That when you get a value like a vector like A and you dot it with a B, the resulting answer is a scalar. Then for this particular one, when we come to the vector product, a cross product, the result you get is a vector, and that is how it comes to be known as a vector product of two vectors. So when you have vectors, you have the i's, the j's, and the k's. So what do we get when we have those j's and k's? When you get I cross I, you get 0. When you get j cross j, you get 0. K cross k, you get 0. So when you are getting the cross product of two vectors, all the terms or the elements that are containing the same unity vectors, shall be just ignoring them because they give us a 0. But those which are dissimilar, which are not the same, like I and j, when you cross them, you get a k. J cross I, you get negative k. K cross j, you get negative I. I cross k. This one was maybe daunting to remember, but we have some scheme here that can enable us to remember. You can see that we are making this. This one is not just along with at this point only, but we are saying that if it is clockwise throughout, if the movement is clockwise, you have it positive. If it is anti-clockwise, you have it positive. What are we meaning here? If you have something like I and you cross it with j, you are starting from I towards j. So from I to j, what type of motion is that? It is clockwise. So that one is positive, and it is a positive k. What about when you have j cross k? J, this one is j crossed with k. What do we get? J cross k, you get I, and it is also positive because from j to k you are moving in the clockwise direction. Then what about when you have k crossed with I? You see that from k to I, it is also positive, it is also clockwise, so we have j. And now this is what you need to take a note of. Of the three, I, j, and k, if I dot this and that, if I cross this and that, the answer should be k. If I cross this one and this one, if I dot j, I, and k, the answer should be j. If I cross, I don't know, it is supposed to be cross, I'm saying cross. So where I say the dot is delete it, it is cross. So j, when I cross it with k, the answer should be I. So it means that whatever is not involved in the cross product is the answer. But that answer is either positive or negative, depending on the face of a kiloco, which we have here. Like you can see, I and j should be k. But when it is I, when I is the starting point and j is the terminal, we have k. Let's have this. When you have I crossed with k, the answer should be j. But it is negative or positive depending on whether you are moving from clockwise or anti-clockwise as you are moving from I to j in accordance to this. So I, k, from I to k, this type of motion is anti-clockwise, so this is negative. Then if I have K crossed with K crossed with J, from K to J, that is negative I. Then from J cross I, from J to I, it is also anti-clockwise. Starting from J, moving like this to I, that is anti-clockwise. So this is negative K. You can just try to examine that pattern and follow along. It is doable. That is what we have. Let's try to enhance our understanding with this example. Given vector A equal to I minus J plus 3K and vector B equal to I plus 4J plus 3K, find A cross B. A cross B, we have 2I minus J plus 3K crossed with I plus 4J plus 3K. So we are supposed to open the brackets and do just like the way you can have any ordinary multiplication. However, when we come to I and I, that one should give us a 0. So what we are going to do, we shall have this multiply this and this one, then multiply that same thing with also multiply also 2I with 3K, because 2I crossed with the I will get us a 0. So start with the 2I and 4J. We have 8. I need to make use of blue pen. 2I, this is 2I crossed with 4J. I'm illustrating here. After this one, I shall be just writing it. So this one is the same as 8I cross J. Now from the clock, I cross J, from I to J, that one is a clockwise motion. So you get a positive K. So this one is 8K. So we have 8K there. And 2I crossed with 3K. 2I crossed with 3K. This one is 6I cross K. Now I cross K, you see from I to K. That one is I to K. That one is anti-clockwise. So you get a negative J. So this one is negative 6J. So 8K minus 6J. The next one is J, negative J. This one crossed with I. Now J cross I is negative. So the overall thing here will be negative and then negative K. So we get K. So this one is plus K. Then we have J, this negative J and 3K. Negative J crossed with 3K. This one is the same as negative 3. Then J crossed with K. And negative 3, J cross K is just I. So we have negative 3I. So I have here minus 3I. Then after that, this one was from J cross 3K. Then we have 3K and we have 3K, this 3K and 3K crossed with I. This one is 3. What is K cross I? K cross I is J. So this is 3J. So I'm adding here 3 of J. Then from here we have just got 3K cross I. We now have 3K cross J. 3K cross 4J. This one is 12, then K cross J. 12, K cross J. From K to J, that one is anti-clockwise, so you have negative I. So this is minus 12I. And we now correct the like terms together. The i's, we have negative 3i, so this is minus 15i. The j's, we have negative 3j because we have negative 6j and plus 3j. Then the k's, we have 8 and k, so this is 9k. That's what we have there. Given the vectors p, this example, to given the vectors p equal to 3i plus 2j minus k and q equal to 5i minus j plus 2k, find p cross q. P crossed with q, we have 3i plus 2j minus k. We are crossing this, cross it with 5i minus j plus 2k, and we have 3 crossed with 5i, that is 0. Then we have 3i crossed with j, that one is I cross j is k. So this one is negative 3k. Then this one is 3i and 2k. I dot k, I cross k is negative j. So this one is negative 6j. After that we have 2 and 5, 2j. This one and this. We have 2j crossed with 5i. I get 10j. This one is supposed to be j cross I, and j cross I gets us a negative. So this is negative 10k. I get negative 10k plus, let's whether this one is positive, this is plus. 10k is coming from j, 2j crossed with 5i. Then 2j crossed with, that one is 4i, because j cross k is positive. Yeah. Then we have k, this one, and 5. K cross I is positive j, so this is negative 5j. Then we have k, negative k, and j. Now k cross j, k from k to j is negative. So there is negative, k cross j is negative, and even actually this is negative and negative. So this is plus I. That is it? Yeah, it should be negative I, because this is negative k and this is negative j. Yes, negative k, negative j, it would get us a positive, but because k cross j is negative I, this is now negative I. Correct the like terms together. The i's, you have 3i. The j's, you have negative, that is minus 11j. And then the k's, we have 13k. We have minus 10 and minus 3. That is p. It is p cross q. This one was not typed, but the vectors are here. M is being required, m cross n. So you have 4i minus 6j plus k. We are crossing that with I minus 2j minus 3k. 4i and I, that one is 0. 4i and 2j, that one is negative 8k. Then we have negative, this is 4i crossed with 3k. That one will get us positive 12j. Then we have this one and that is plus 6k, because j cross I is negative k and the original it was negative, so that is 6k. We have 6j crossed with 3k, that is 18, because j cross k is positive I, so that is 18i. Then we have k crossed with I, that one is j. Then k crossed with j, there is k cross j first of all is negative I, and then the k, the negative to here, will render this one a positive 2i. And we have that putting the i's together, we have 20i, plus putting the j's together, we have 13j. Then the k's, we have negative 2k, because this one is 6k and then negative 8k. That is m crossed with n. There are some concepts we need to take note of here. I think from what we have seen, maybe actually we have not seen it maybe, but we are going to look at it. We are going to observe that a cross product is not commutative. Having a cross b is not the same as b cross a. When you start with a, instead of starting with b, you get something different. Particularly, you get the negative of the other one. So a cross b gives us a negative of b cross a. And that also means that b crossed with a, you get a negative value of a cross b. That is what we need to take a note of. The other important thing is here, take a note of this statement here, that a cross b is perpendicular to both a and b. They are at right angles. So if they want a vector which is normal to a and b, you just get a vector product, and that vector will be normal to either a or b. It will be actually normal to both of them. So take a note of that. And then I think you have already realized that a cross product of two vectors is also gives another vector. But for like the other one we had, the other time we had the scalar dot product, it was giving us a scalar quantity. This one is a vector quantity. A cross product of two vectors is another vector. There is a method we can use to determine the cross product of two vectors. It is known as the determinant method. And if you have vectors A with these components and vector B with those components, this is how we can render a cross product of two vectors. You just get the determinant. You know how you can determine the determinant of the 3x3 matrix. That is what we do, and we can get the cross product. A cross B, you have the I, the J, and the K. Then you write the components A1, A2, A3, just the coefficients of the components. Actually, the components. Then B1, B2, B3. And when you say A cross B, you should start with A up there, then B down. If you have B cross A, it will be B up and A down. So the components of A are aligned up there, and the components of B are aligned down. And what you do like for I, you start with this I, and you cancel this and this. Then you have A2, A3, B2, B3. That is what you are having here. A2, A3, B2, B3. Then after that, we shall have J. You come to J. When you come to J, you have that. Cancel that. Cancel that. In other words, you have that J is on the first row and the second column. Those are the rows and columns you cancel out. So you cancel out the first row and the second column. Then the values which remain is A1, A3. You can see A1. Then B1 here, B3 there. That is for J. Then for K, you have for K, this is what you have. For K, this is that is the K, and you cancel that and you cancel that, and what remains is actually the K. You just have that K crossed, a cross. You draw a cross at K, down, up, downwards. Then from there, and what remains is A1, A2, A1, A2, B1, B2. And after that, after doing that, now this is I. To get the component of I, you just get this determinant. And the method which we use there is product of elements on the leading diagonal multiplied by subtracting the product of elements on the minor diagonal. So you have A2, B3 minus A3, B2. Then this one is A1, B3, this one minus A3, B1. There you are. Then we have A1, B2, A1, B2 minus A2, B1. That is what we have, and that is how we can get the. When you work out these ones, you are there. And now, somebody may be wondering what is happening. Why that negative? The others are positive. What do I do? The fact is that you must have plus, minus, plus. So you have the first one plus, then the second one here must be minus. That is a rule you must follow if you want to get it right. So have a negative and as for the component of J. So we are saying that the signs of the cross products in I, J, and K of A cross B are plus, minus, and plus respectively. So the I is positive, the J has a negative sign here, and then a positive sign for the K. It does not mean that always that the answer should always have a negative J, the final answer, because you can have that the product, this A1B3 minus A3B1 may be negative. So if this difference is negative, then you can have a positive for I. So, but when you are writing it, these ones, it must be like this: plus, minus, plus. Take note of that. We shall have actually in the file which you copied, which you got from the file you got from Telegram, the file you downloaded from Telegram, it has these things interchanged. There is some interchange around this place, so you take a note of it and change it accordingly. I started with the minor diagonal instead of the leading diagonal. It is supposed to be A1 B3 minus B1 A3 or A3 B1. That's what you are supposed to have there. Correct it. This example is supposed to help us illustrate some. It's supposed to help us use the determinant, practice some use of the determinant formula. The determinant method of determining the cross product. They have given us those vectors, and they want to find A cross B. A crossed with B. The determinant holds that you have I, J, and K. Because A is the first one there, I have the components. For I have 2, for J I have 4, and for K the component is -1 from here. Then B, In the I have 5, I have 3, and then 6. And this will hold me, we shall have this one. When I have I, cancel the first row and the first column, and remain with 4, -1, 3, 6. Subtract j, because the rule should be plus, minus, plus. When you come to j, this one is not there. Cancel this and that. Remain with the 2, -1, 5, 6. You are considering j, which is in the middle, so the middle column is not taken. You just get the other 2 columns. Then plus k. You are considering k, you remove, you don't consider that column. So you have 2, 4, 5, 3. And what remains is at the end of it. This one is 24. 24 minus -3. That is I, minus. This one is leading diagonal. It is 12 minus -5. That is j. Then plus 4k. This one is 6 minus 20. And that is k. Then you have 24 minus that one, that is 27. I minus, this difference is 17. So that is 17 I minus 6 minus 20 is negative. So that is 14k. That is the dot, the cross product of those 2 vectors. The second one is B cross A. So we have I, J, and K. Then B is 5, and then 3, 6, and we have for A we have 2, 4, -1. The order is very, very important. Like here A is first, you have A up. Here B is the first one, you have B up, then B, then A downwards. And we shall have now I, for I, we have the determinant, which is 3, 6, 4, -1, minus j, and the determinant is 5, 6, 2, -1, plus k, and the determinant, which is 5, 3, 2, 4. This will get us this -3 minus 24. This one is I. Then minus 5 times negative, and that is -5, minus 12. This one is j. Then plus 20 times 4, 5 times 4, that is 20, minus 6. This one is 4k. And the final thing is -27 I plus 17j plus 14k. And you realize that if you take note of this one is like having this one negated. So the negated version of this one is exactly that. So it is trying to underline the fact that B cross A is negative of A cross B. Yeah, this one is negative of this. Negative. This one was 27 positive, come negative. Every positive component has become negative, and everyone which was negative is now positive. The other one is A cross B. We have A cross B dotted with A. Now A cross B is there. This one is A cross B dotted with A. So A cross B is 27 minus 17J. This one is 17J minus 14K, and we are dotting it with the A, vector A, which is 2I plus 4J minus K, and we shall have this one is 54 if you multiply the i's, and then for the j's I have 68. Then for the k's I have this one is plus 14, and when I work out this I'm getting a 0, and that one is supposed to, it is illustrating the fact that A cross B is perpendicular to what? To A. So you are having this vector which is A cross B. When you dot it with this one, you are getting a 0. And remember, we say that when you get that a dot product of two vectors is 0, it means that the vectors are perpendicular to one another. You can note that you can check this. If you get A cross B and you dot it with the B, you are also going to get a what? A 0, because A cross B is perpendicular to either, to both of them, to both A and B. So the dot product of those ones should give us a 0, because you are getting A cross B, you are dotting it with B, and A cross B is perpendicular to B and also perpendicular to A. That is what we have there. Find, this is another example, find a unit vector which is perpendicular to the vectors 2i plus 3j plus 2k and I plus 4k. So we shall let that vector be n, let the normal vector be n. So we have that n is equal to 2. We can just have that it is I, j, k, 2, 3, 2, and then this one is 1. There is nothing in the j for this one, so we have a 0 there. Then 4, and we have that this n, if I work out everything, this one in the I have 3 times this one, so this one is 12i. For j, I have 2 times 4 minus that one, so that one is a minus 6 in the j. When it comes to k, I have 2 times 0 minus 3, which is minus 3k. And now this one is a vector which is perpendicular to these two. This vector is perpendicular to all of these ones, but you want a vector which is unit. This one is perpendicular to the vectors, but it is not a unit vector. So we need to get n cap, which is got by getting n divided by that, and this one is 12i minus 6j minus 3k divided by square root of 12 squared plus negative squared plus negative 3 squared. The final thing here is 12i minus 6j minus 3k divided by square root of 100. If you work out those values, you are going to get 189 as the value there. So this one is a unit vector which is normal to, it is a unit vector which is parallel to this n, and since this n is normal to the other two vectors, so this is a unit vector which is normal to these two. I guess it's making sense. N cap is parallel to n. but this n is perpendicular to the other two vectors. Every vector which is parallel to n is also perpendicular, is also normal to the other two vectors. So this one is a unit vector which is parallel to n, and so it is perpendicular to these vectors 2i plus 3j plus 2k and I plus 4k. Given the following vectors, this is another example. Given the following vectors, you can see them. They want to find A cross B. First of all, A cross B. I shall use the determinant method, I, J, K. A is 1. This one is negative 2, 4. Then B, 3, 4, 7. And the determinant I have for I have negative 2, 4, 4, 7 minus J, and for J I have 1, 4, 3, 7 plus K, and this one is 1, negative 2, 3, 4. After which I have for I have negative 14 minus 16. This one is I. Then minus 7 minus 12. This is J. Then plus this is 4 minus negative 6. That is K. And finally I have this one is negative 30 I. Then we have a minus, and this one is also a minus. 7 minus 12 is minus. Suppose to get us there you are. That is A cross B. Then Roman 2, we have B crossed with C, I, J, K. B, it is 3, 4, 7. And C, it is 2, 1, 5. And we shall have I, and the determinant is 4, 7, 1, 5. I told you when you want to have I, cancel this and that, and what remains is this part. Forget about the column that contains that I. Don't consider it. Consider the rest. Then minus J. When you consider J, the column which contains this is the one you leave out. So you have 3, 2, 7, 5. When we come to K, leave out the column containing K. Have 3, 4, 2, 1. And there you are. This one is further. 20 minus 7. That is I, minus 15 minus 14 for J, plus 3 minus 8 for K. And this is negative. It is not negative, please. It is 13I. 14 minus 15 minus 14 is 1. So this is minus J. And then 3 minus 8, that is 5. So this is minus 5K. This one is asking for A. It is asking for A crossed dotted with B cross C. I think that's it. A dot B cross C. So this B cross C is not perpendicular to that, so the answer is not 0 because this A is not a part of this cross product. So it has you get some answer there other than a 0. Now we have B cross C, we already have it. It is here, and the vector A is I. So we have I minus 2j, then plus 4k. You are dotting it with the B cross C, which we have as 13I minus j minus 5k. And for this one you go component by component. So this is 13 plus negative 2 times negative j, that is 2, plus 4 times negative 5, negative 20, and this one is negative 5. The other one is asking for, this one is B, it is C dotted with B cross A. And now B cross A, first of all we shall make use of this one, that B crossed with A, I get the negative of B, not B but I get the negative of, it is the negative of A cross B. So it is A cross B, already have it. We got it as it was negative 30, that is 35, 10. That is what we got. And now the negative version of that, this one is 30I minus 5j minus 10k, that is B cross A. And now they want to have that one, B cross A, we dot it with C. So C dotted with B cross A. C is, we know that C is the vector 2I plus j plus 5k. We are going to dot it with 30I minus 5j minus 10k. The 2 and the 30 gets us a 60. Then I and that one is G and J. The J's are going to get us negative 5. Then the K, this one is another negative because we have 5k times, so this is negative 50. And so this is 60 minus 55, which is equal to 5. We are getting a 5. So this one is asking for a dot product of B and A cross C. A cross C is something we have not yet got. We can just get it here. We have I, J, and K. Vector A is 1, is having these components here, and then vector C has the components 2, 2, 1, 5. And this determinant is negative 14I plus 3j plus 5k. I believe you have learned something about this, how we get that. So at this point we just have I, then this is negative 10 minus 4, which is there. Then j, negative 5 minus 8. That is what we have. And remember, it was negative of negative 5. It was negative of 5 minus 8. So at the end of it, you have a positive 3j. And for this one, it is negative. This is 1 minus negative 4, which will get us a positive 5k. After that, we shall need to now get the dot product A cross C. And now vector B is the vector 3, in the I plus 4j plus 7k. That is the vector B. We are dotting it with the crossed vector we obtained, 3j plus 5k. When you look at the i's, I get negative 42. That one is 3i times negative 14. When I look at the j's, I get 12. When I look at the k's, I get 35. And the overall thing I get is 5. That's what we have there. Let's do this. Find a vector of magnitude root 5 units and perpendicular to the vectors A equal to I plus 3j plus 6k and B which is equal to I plus j plus 2k. We need to find they want us to find the vector which is perpendicular. And whenever they talk about a vector perpendicular to the others, and you have two vectors, a vector which is perpendicular to both of them is first of all a cross product. So you shall get a certain vector n which is equal to A cross B, and this one is it is A first, so we have 2, 3, 6, followed by B, 2, 1, 2. The 2, they are this one, 2, the 3 and the 6. This one was up there. Then 2, 1, 2. They are the coefficients they are the components. And for I, we have 3, 6, 1, 2 minus j. This one is when you come to j, j is that one. So you consider 2, 2, 6. 2, 6, 2, 2. When it comes to k, that is k. What remains is 2, 3, 2, 1. So we have 2, 3, 2, 1. Now we are going to this one is 6 minus 6 for I. Then the determinants, we are getting determinants. Product of elements on the leading diagonal minus the product of elements on the main diagonal. So we have this one is 4 minus 12 4j plus this one is 2 minus 6. This one is a 0, so we have negative 8 from here, then the negative here. So this one is 8j. This one is 2 minus 6, so this is minus 4k. This vector is perpendicular to the given vectors, but its magnitude is not root 5. So we are going to first of all get a vector which is having a magnitude of root 5 from this. So we shall get a vector n cap which is equal to n divided by magnitude of n. This is 8j minus 4k divided by square root of 8 squared plus negative 4 squared. The resulting thing is 8j minus 4k divided by square root of 8, which we can write as 8j minus 4k divided by 4 square root of 5. And this vector n cap is now, you can reduce by 4. This is 2j minus k over root 5. This is a unit vector which is parallel to this vector n, and every vector which is parallel to n is perpendicular to the other two vectors. So I want to get a vector which has a magnitude of root 5. So we shall multiply this vector by root 5, because once you multiply a number by a unit vector, the resulting vector has the magnitude of that number. That means that the required vector is square root 5 of 2j minus k divided by root 5, which is equal to 2j minus k. That is the vector. This vector has a magnitude of root 5, and it is perpendicular to this vector here. It is normal to this one, and being actually not normal, it is parallel to this, and being parallel to this one implies being normal to A and B. That's what we do. The vector is there.